Alright, so we're going to do a video real quick on the basics of trigonometry. And trigonometry is really important in physics, and so we do right triangle trig on a lot of different problems. So we're going to have a little mini unit here on just trigonometry. So if you are listening to this just because you have a sub, make sure you do what the sub tells you. Also, go ahead and get out your notebooks. Alright, so trig is a branch of mathematics that deals with relationships between sides and the angles of triangles. And so how does this relate to physics? You will find that out as you move forward. Right now, you just need to focus on how to actually do it. It's not hard. It is something you've done before, but we're going to review. Alright, so the parts of a triangle. Every right triangle has the same parts. You have the hypotenuse, the long side, you have the opposite side, and you have the adjacent side. The adjacent and the opposite side are based on which angle is labeled. So in this particular example, you have this angle labeled. So that means your opposite is going to be opposite that angle, and your adjacent is going to be the one that is adjacent to the angle. So just right there. So keep that in mind. It depends on where the labeled angle is, and the hypotenuse is always the long side, or the side that is opposite the 90-degree angle. So on a right triangle, you always have this 90-degree angle. So the hypotenuse is always across from that. Alright, so this is the most important slide on the whole thing. Make sure that you write it down. And if this video is running through the slides too fast, if you need to, after the video is over, if you need to go back and write something down, then the sub will have the PowerPoint open, and he or she can put it back to wherever it needs to go. So I'll leave it up for a little bit longer, but these are your basic equations for the trig functions. You have sine, cosine, tangent, and obviously you have the SOHCAHTOA. You probably heard that from geometry class, but those just help you remember what the equations are. So they're all written as, you have sine of theta. Theta is the angle. So theta means whatever the angle is. Opposite is the length of the opposite side. And of course, hypotenuse would be the length of the hypotenuse. For cosine, you have theta, that's the angle again. You have the length of the adjacent side divided by the length of the hypotenuse side. And then for tangent of the angle, you have the length of the opposite side over the length of the adjacent side. So this is a really, really important slide. And then of course you have Pythagorean theorem right here. A squared plus b squared equals c squared. And you can use that to find, if you have any two of the three sides, you can always use that to find the third side. Alright, so I'll switch this. Y'all can watch this video. After, this is just a goofy video with a Will Smith song in the background. It's kind of cool. But you can watch it after. But I'm going to go over the problems that are on here. So this is example 1. And we need to find we're walking up a hill, and we know the height of the hill, and we know the incline of the hill. And so we're going to say how far we have to walk to the top. So on your paper, write out this question and draw the triangle as it is drawn here, labeling the sides that you know. So go ahead and take the time to do that. And I wish the trig function that we used wouldn't have just popped up like that, but it looks like it did. Alright, so obviously the trig function for sine popped up, but how do we know that that's the one we needed to use? So the way that you do it is you look at your angle and label your sides. So I have this angle labeled. That means my opposite is going to be this one. My adjacent is going to be that one. And then of course my hypotenuse right here. So to pick the trig function you're going to use, you have to look at what you have and look at what you want. So we have the 500 meters on the opposite side. So we have the length of the opposite side, and we want the hypotenuse. So because we have the opposite and we want the hypotenuse, we have to use the only equation that has those two in it, which is, or the only trig function that has those in it, which is the trig function written for the sine of the angle. Okay, another thing that's really important before you start solving this problem, the calculator that you're using needs to be in degree mode. So if you take your calculator and you hit mode, go down, and it's going to be radian or degree. Go over to degree mode, hit enter. Do that now before you try to work the problem. Okay, so now we're going to use the sine function, and we have to solve for the hypotenuse. Now, this is basically just a three-variable equation. You have the sine of the angle, which if you have the angle, typing in the sine of that angle will produce a number, and then you have the opposite side, which you have, and then you want the hypotenuse. So I need to rearrange this for the hypotenuse. So if I'm going to do that, the hypotenuse is in the denominator. That means that these two can switch. So rewritten to solve for what I want, this is opposite over the sine of theta. And then I can plug that in. This would be 500 meters divided by the sine of theta, which is the angle that you're given, so that's the sine of 12. Alright, so you can plug that into your calculator. Make sure that you put parentheses around the 500 before you do that. You also probably put them down here too. So we do 500 divided by the sine of the angle, sine of 12, and you get 2404.9. So 2,404.9 meters. So that is the answer there. And then, if you think about it, that makes sense. You have a very slight angle, and so you're going to have to walk quite a ways to climb up 500 meters at such a small angle. So that number makes perfect sense. All right. So now let's work the next one. Hopefully you got that down. So we're going to work one now where you have to solve for the angle. Okay. So on this one, we have a ladder. Go ahead and write this one down. So we have a ladder that's 12 meters long, leans against the building, rests on the wall at a point that's 10 meters above the ground. So you can look at how this is labeled. You got the length of the ladder, you got the height of the wall that it leans up against, and you're trying to find the angle the ladder makes with the ground. So I am trying to find that angle right there. And so again, you look at, if you're trying to solve for an angle, you still have to look at the sides that you have. So in order to solve for an angle, you have to have two of the sides, and that'll get you an angle. So if I want this angle right here, I have to, this is my labeled angle then. My opposite side is over here, that's up against the wall, and then my hypotenuse is something I have as well. Now I don't have the adjacent side, but I could easily find it with the Pythagorean theorem because I have two of the three sides. But in this case, there's no point in finding the adjacent side. If the problem asks what is the distance between the wall and the base of the ladder, then you'd find it, but there's no point. You just want to know this angle right here. So we're looking for that angle. So again, I'm using the sine of theta because I have the opposite and I have the hypotenuse, and so that means I'm going to use this trig function. So make sure you know how to label a triangle. Again, if this is the labeled angle, the one across is opposite. The long side is always the hypotenuse, which means the adjacent is the one left over. Okay, so I'm trying to solve for an angle. So I'm going to write this out. Sine of theta. I already have the equation written, so now I'm just going to plug in what I have. My givens are on the triangle. If it helps to write out your givens, that's fine, but if I were you, I would just label what is what. So I have opposite and hypotenuse on the triangle so you know what you have. So the opposite is 10, and the hypotenuse is 12. And we can put the units in. It's not going to make any difference for this particular one, since it's a ratio. They're going to get canceled out anyway. And the trick here is to make sure you do this correctly. The angle, if you're going to solve for an angle, you have to take the inverse sine of both sides. So you multiply this side by the inverse sine. You multiply this side by the inverse sine. So this will cancel. You'll be left with just theta. So theta is going to be equal to the inverse sine of 10 divided by 12. And again, units here aren't necessary. Since it's a ratio, they're going to cancel out. So let's see what you get. So on your calculator, the sine inverse, you have to hit second sine. And then in the parentheses that come up, you can just hit 10 divided by 12. And you get 56.44. So the angle here is 56.44 degrees. And that number makes pretty good sense. When you look at the picture, you look at how it's set up, 56.44 degrees makes sense. If you would have gotten like 1 degree, then you know something's off. Either you picked the wrong trig ratio, or you didn't plug it into the calculator correctly, or you didn't have degree mode on. Okay? Alright, so there's 2 examples. Now, when the sub is here, I expect you to work on the trig packet. The trig packet has quite a few problems on it. And at the end of this PowerPoint is the answers to those problems. I want you to work the entire front page, so the entire first page, front and back. So that is 1 through 6. You need to work 1 through 6. All those triangles, all those different things. On the first one, you're just labeling sides. On the second one, you are writing what the ratio is. And all of them are tangent, so you're just writing what the ratio is. So again, it's just labeling sides and picking that. And then on the third one, you actually got to start solving for sides. Fourth one, you're solving for angles. Fifth one, you're doing the cosine function, solving for angles. So just reading it, see what it says, and if you are the sub, please put the answers up. Those are at the end of this PowerPoint. Alright, have fun, guys. Tomorrow we're going to do a lab. We're going to go outside. So be ready for that. We're going to go take the heights of different objects, and then you'll have more time to practice after the lab.